Hello everyone, welcome to this video. In this video, we'll be talking about operators related to T. So in order to understand the proof of this spectral theorem relating to spectral family, we have to first understand the operators related to T. We already know that B represents the positive square root of T square, right? T positive, that represents the positive part of T, right? And this T negative represents the negative part of T, and we can define all of them as defined here in equation number 1, right? That you already know. And moreover, this E operator that represents the projection of all of the given Hilbert space onto the null space of T positive operator, right? Now we could also define the operator T and B using the equations T positive and T negative. Here we could just add and subtract them in order to obtain the algebraic relation between T and B. So you see, you could write this T as half of B plus T minus half of B minus T. Why? Because this half B and half B, both of them cancels out with each other, and so you finally reach out to T. So you see, what is this thing? This is the definition for T positive here, according to this definition here, right? And you see the next term is nothing but T negative. This next term here is T negative, right? So using all these things, you are now able to write the operator T as T positive minus T negative. Similarly, you could write this operator B here as T positive plus T negative. So these are also the two expressions. Now, what are the operators which are related to this operator T? So we have, with the given operators we have just defined, we have the property that the operator B, the operator T positive, and the operator B negative, the positive square root of T square, this one, the positive part of T and the negative part of T, all three of them, they are bounded as well as self-adjoint. Until now we only knew that the operator T was bounded and self-adjoint. Now the operators corresponding to these operators, that means the positive square root, the positive part and the negative part, are also bounded and self-adjoint. The second property here tells us that these three operators, B, T positive and T negative, they commute with every bounded linear operator that T commutes with. So that means, suppose you have some operator S which commutes with T, right? So this operator S would definitely commute with B. It would commute, this S would commute with T positive, and this S would commute with T negative as well, right? So this is what they are saying. And in particular, you have why? Because all of them, they commute with T. This B commutes with T, right? So in that case, you would have BT is equal to TB, T positive, T is equal to TT positive, and these expressions as well, right? Similarly, for the third property here, the third property about this projection operator, they are saying E commutes with every, this E here represents the projection operator. So this projection operator here commutes with every bounded self-adjoint linear operator that T commutes with, right? So this E also commutes with the same. So this is what the third property says. And the fourth property here tells us that all of these properties are also true. So the first property here tells us that when we have the composition of the positive part and the negative part, that is a zero operator. And similarly, T negative composed with T positive, that is also a zero operator, right? This is also operator. Why? Because we on both sides we should have the same kind of things. Because on the left hand side we have operator, so on the right hand side we should also have operator, right? Then T positive E is equivalent to zero operator, and T positive is also equivalent to zero operator. And when you have this negative thing, that is the T negative operator. You will see later why this thing happens here, right? When we are doing this proof, Then we have TE, that is equal to minus of T negative, right? And then when you have Ti minus E, that is equivalent to T positive operator. Now we'll be seeing why all of these things are true. So you just have to remember that all of this E, they are nothing but, when you collect all of them, they would form the spectral family of the given operator T, right? Okay, and moreover, this T positive and T negative, both of them are the positive operators. So these are the operators which would be connected with T. In the next video, we'll be looking at the proof of all of these properties. Well, that is it for this video. Thank you for watching.